As seen in the previous examples, if we have a base and a negative exponent, in order to make that negative exponent into a positive, we can move the base and the exponent into the denominator. If instead you have a base and a negative exponent in the denominator, you can actually move the base and the exponent into the numerator, and that will also make the exponent positive. So we would have a to the n, we'd be left with a 1 on the bottom, but this is the same as a to the power of n. Now this rule works for similar reasons that we discussed as for that initial negative exponent law. In order to make this negative 8 exponent into a positive, we'll have to move it along with its base of m into the numerator. So we could write the question as m to the 8. In the denominator, we would still have a 1, but of course we don't have to write that. For b, we have a negative 7 exponent on the bottom. So to make that negative 7 into a positive, we'll move it and its base into the numerator. So in the numerator, we still have this p. So I'll write the p, and then multiplied by the q to the power of 7. With c, we have this exponent of negative 3, so let's move it and the 4 into the numerator. So equals 4 to the power of 3. You'll notice that I didn't put the 1 because if you go 1 times 4 to the power of 3, that 1 is not going to change the value, so we don't really need to write it. And 4 to the 3 is 64. D is really similar to C. We'll move that exponent of negative 4 with its base of 2 into the numerator. So 2 to the power of 4, and that equals 16 if we simplify.